Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hello and welcome to Coding Bootcamp's Intro to Object-Oriented Programming course in Python. In this video, I'm just going to go over what the course covers, what you can learn from it, and a couple of the projects we'll be going over. If you are interested in taking this course or other courses related to Python or other programming languages, be sure to follow us on social media like Facebook, where you can keep up to date with all of our updates and news about the website. So my name is Daniel. I got my bachelor's degree in computer science from a college in upstate New York, SUNY Oneonta. I've been a math and coding tutor for 4 years, and I have experience with C++, Python, Java, SQL, and HTML. If you haven't taken this course, be sure to take our Intro to Python course, where we go over the very basic concepts you need to start coding in Python, like loops, variables, things like that, because this is a more advanced course. So these are some of the topics we're going to be going over in this course. We're going to talk about what is object-oriented programming in Python. Just to give a very simple explanation, it's about building a program around objects and then the relationships between those objects. There's other ways of programming, but that's the most basic definition of object-oriented programming. We'll learn about classes, class instances, inheritance, and extending the functionality of a parent class. So a class is kind of like a template for a programmer to create his own types of objects. So if in the intro course you might have seen like you define variables that are like integers, floats, or like strings. But in a class you can create a template where you can create your own objects with your own methods and your own attributes. It helps organize your programs a lot better and makes them work a lot more fluidly. We'll also learn about instances and instance attributes. So an instance is one object created from the class template. So if you have a car class, then a single car would be an instance of the car class. You'll also learn about inheritance, which is when a class uses another class. So it's the same thing when we say extending the functionality of a parent class. Inheritance is about the relationship between two different classes, where one class adopts the methods and the attributes or the variables of another class. So for example, you could have a vehicle class and you could have a car class, but a car is a type of vehicle, so you can have the car inherit the vehicle class, and then it adopts any methods and variables that go along with that vehicle class, and you don't need to rewrite code. So that's just the topics we'll be going over, and then these are the 3 projects we're going to be doing. We're going to create a car class with 3 subclasses. So we'll have a main car class, and then we'll have subclasses like convertible or sedan that are more specialized versions of that car class and have add extra methods and are more specialized. We'll have a Guess the Rolling Dice program, which we have 2 players play against each other, where they guess a number between 1 and 6, and then we roll a die. And if the die number is the same as the number the player guessed, then that player scores a point. Then the winner is the one who has the most points at the end of the game. And then we're going to create a full blackjack game in Python, which is going to be the longest project. And it'll probably be 200 to 300 lines of code, and it's just going to play the casino game blackjack, but in a Python program. So we'll have classes represent the players and the player hands, and then also the deck and the cards. And we'll have players play against each other in the dealer, and then we're going to use a point system instead of money, because it's easier from a programming perspective. So I hope that explained what this course is about. Again, be sure to follow us on Facebook and any other social media, where you'll find updates about the courses we're going to be offering, and see you later. Thanks for watching. Bye. Hello, my name is Daniel. In this video I'm going to explain how to download Python on your computer and create your first Python program. In this video I'm going to cover how to download Python, which is the language, how to download an IDE, which is a text editor. IDE stands for Integrated Development Environment. So it not only allows you to write your code in a text editor, but it also allows you to check it for errors and run your programs. And then we're going to build a one-line program just to show how the editor works. So to begin, open up a web page or a web browser and go to Google and type in Python. It'll bring you to the Python website, which is python.org, and then you can click on Downloads. That'll bring you to the Downloads page. And these are all of the different versions of Python that have been released over the years, going back even over a decade. So if you go all the way to the bottom, the most popular and most used ones are here at the top, and it tells you when they're going to stop being supported by the website. And we want the most up-to-date version of Python, which is up here at the top, 3.8.6. So I use Windows, so I would click on this button, but if you're using Mac or Linux, you can click on these other links. So if you're using Mac, click on this. And these would be all the releases for the Mac version. And then if you want to download Python for Linux, you click on this, and these are all the Linux versions. But I use Windows, so if I were to download Python, which is already installed on my computer, I would click on this button. And then Python would start downloading, and you'd open it up, and then a window would pop up, and it would just ask you, do you want to install Python? You would click Install, and then just click Next. It'll set the default file path for you. You don't have to worry about that. And then as long as Python's installed somewhere on your computer, you will be able to use an IDE or text editor to write Python programs. So once that's downloaded, we need an IDE. So I'm going to go to Google again, type in PyCharm. It'll bring me to jetbrains.com, which has the PyCharm IDE. Click on PyCharm, click on Download, and this is the download page for the IDE or the editor. So there's two versions. There's the community version and the professional version. We want the community version because it's a free download and it's used for educational purposes, or like hobbyists, things like that. The only time you want the professional version is if you're trying to build programs or applications that are used for some kind of financial gain. And usually there's documentation on the website that explains how much money you need to be making before you're required to use the professional version. But for now, since we're just using this for educational purposes, we're going to need the community version. So click on Download. And then the download will start, and it'll take a few minutes. I'm going to cancel this because it's already on my computer. And then once PyCharm's downloaded on your computer and Python's downloaded on your computer, then you can build your first Python program. So I'm going to open up PyCharm. So when you open up PyCharm, it's going to ask you to create a new project, and just click Create or click Start. And then you should see, this is what the IDE looks like once it's created a new project. The project's on the left, the file collection. So this is all the project, but the main file we're going to be working on code in is main.py. Which is a Python file, and where we're going to be editing all our Python code. In the center is where we work on code. So let's say I had this statement, print hello world. So this statement would print hello world in the bottom of the editor, where all of the output of our program shows up. So if I wanted to see that output, I would click on the green arrow at the top right, and that says Run, which runs our program. And then over here on the bottom, you can see we printed the statement hello world using the print keyword and putting in some text. So if I wanted to print 5 hello worlds, I would do this. I would put in 5 statements, and then I would run my program again. And then every time I run the program, it would execute the code I've written. So it's nothing's going to appear at the bottom until I click that button. But once I do, we see 5 hello worlds. So that's how you build your first Python program. This is just a simple set of print statements to print a message. Just one other thing about Python is in English we have a period denote the end of a sentence. So if you have some kind of statement, you would end it with a period to say this is the end of the statement. In C++, use a semicolon. So C++ is another coding language. So if you had a print statement like this in C++, the syntax is a little different. You would end it with a semicolon to be like this is the end of that statement. In Python, you don't put anything. You just begin a new line, and then each new line is a new statement in Python. So that's just one feature of Python that makes it look very clean when you're editing code. Python has a lot of features like that in the syntax that just make it clean to look at. That's why people like it a lot. So yeah, that's how you build your first Python program. You can use other text editors like IDEs like Visual Studio. Visual Studio is Microsoft's text editor, again IDE, and it looks a lot different, but well, not too much different. It's just like the coloring and stuff is different, but it lets you edit your code, run your own programs, and it can be used for Python. I've only used it for C++ before. I chose PyCharm for this video. And then just one other thing about Python versus other languages is if you're coding in C++, you're usually using, or you're always using, a compiler. And in Python, you're allowed to use an interpreter or a compiler. So in Python, when you use an interpreter, it will run all of the code up until your first error, and then it'll stop and tell you what the errors are in your program. If you use a compiler, the program isn't going to run even if some of the code is working unless the entire program runs. So just to show you what that looks like, since this is using an interpreter, if I have an indent here, that's going to throw an error, and then the line of the error is going to be spit out at the bottom where the program output is. It says line 2, there's an error, and it says there's an unexpected indent. So the reason that there's an error here is because indents are for blocks of code, and I'm not trying to assign a block of code to anything. So this indent doesn't do anything, so it's giving an error. So yeah, that's how you throw an error, and what an error looks like on the bottom. If I put it back to normal and I run, I won't get any errors, and I'll see both my hello world statements. So actually this my editor is set to compile mode, or it's a compiler in compiler mode. So that's why you didn't see any hello world. So if I printed out like 6 of these and I ran, you see 6 hello worlds, but then if I threw an error, you don't see any of the hello worlds because it's in compiler mode. But if you use an interpreter, you would see 5 hello worlds, and then you would see the error after it, because interpreters always run up to the first line of the first error line. The benefits of compilers are usually they're easier to work with bigger collections of files, but an interpreter lets you see coding errors a lot more easily because it'll stop the code and throw an error at the line the line stops working. So yeah, that's just a basic introduction to how to download an IDE, how to download Python, and build your first Python program. If you want to check out more about Python, you can check out coding-bootcamps.com, where we cover the language and we go over.
Thanks for watching. Feel free to add your questions as comments down below.
Instructional videos and offer teaching instructional videos for different things on Python. So yeah, if you wanted this, if you enjoyed this video and you want to check out more about Python, you can check out coding-bootcamps.com. Thanks for watching. Bye. So in today's video in object-oriented programming in Python, we're just going to answer the question, what is object-oriented programming in Python? And just explain what that means about the structure of a program and why it's favorable in Python. Just to give a reminder, if you haven't taken our Intro to Python course, the link is up here at the top. It is a prerequisite for this course, so you should be taking it before you get into these concepts because they're more advanced. We cover things like arrays, loops, just very basic introductory programming concepts in the intro course. This one's going to be more about the structuring of programs and how to manage objects, things like that. So yeah, the link's at the top over here. So I'm just going to get into what is object-oriented programming in Python. Object-oriented programming is a programming paradigm that provides a means of structuring programs so that properties and behaviors are bundled in individual objects. For example, an object could represent a person with properties like a name, age, and address, and behaviors such as walking, talking, breathing, and running. Or it could represent an email with properties like a recipient list, subject, and body behaviors like adding attachments and sending. So basically what that means is, and this is from the course docs, but what that means is everything you're doing in a object-oriented perspective is based around the creation of objects, properties associated with those objects, and then functions that operate on those objects. So what that all means is if I create an object, that would be a noun. So you could create a person, and that would be an object, and an object's a noun. But that person could also have certain adjectives that go with that person, like a name, a height, a weight, an address they live at, age, things like that that describe the person. Those would be the adjectives, which are like variables that hold certain values to define, help define the object. And then that person can also have behaviors like walking, running, talking, things like that. And those would be like functions or verbs. So objects would be the nouns, adjectives would be the variables, and then verbs would be the functions that operate on the objects. So that's the way we think about programming when we're doing object-oriented programming. And Python supports object-oriented programming, so that's what we're trying to cover in this course. To go back to the course docs, put another way, object-oriented programming is an approach for modeling concrete, real-world things like cars, as well as relations between things like companies and employees, students and teachers, and so on. Object-oriented models real-world entities as software objects that have some data associated with them and can perform certain functions. So again, it's just you have objects, those objects interact with each other through functions, and they have certain variables that describe values associated with those objects, or like adjectives. Another common programming paradigm is procedural programming, which structures a program like a recipe, and that it provides a set of steps in the form of functions and code blocks that flow sequentially in order to complete a task. So we're not getting into procedural programming. If you want to, you can look some of that up on your own, but this course is about object-oriented programming. In object-oriented programming, everything is based on objects, but in procedural programming, it's just, you don't define objects, you just execute a series of steps. And Python can be coded in that way, but that's a different way to treat the language, and it's a different way to model a program. But the key takeaway for this video would be that objects are the center of object-oriented programming in Python, and they don't only represent the data, as in procedural programming, but the overall structure of the program, and like the idea behind how you're trying to accomplish what you're trying to accomplish in your programs. So I'm going to get into classes a little bit in this video, just to explain what an object is, and how they can relate to each other. Although the next video is when we're really going to start getting into classes. So I have a sample program I've been working on here. It is a blackjack game. So I wanted to create my own blackjack game, but instead of using money, it would just use points and keep a tally of how many times players beat the dealer. And I defined a bunch of objects to represent different things in the game. So there's the player object. The player object would just be, you can enter your name, and you'd have a score associated with your name, and that would be the player object. You also have a deck object, which represents the deck, which deals cards to players. And then that deck is based on the card object, which is an individual card. And cards have different attributes, just like a deck and a person do. So the simplest objects you would have to define in a blackjack game would obviously be a card, since the entire game is based on cards. So in the card class, so just to explain what a class is, a class is a user-defined object. So if you had like the line x equals 7, this will create an integer object in Python automatically. So if I did, well, actually, this isn't a finished program, but if I did a print statement and I found the type of this object, it would tell me it's an integer, and the integer would be type, or the object that I just created, and it would have the value 7. But if you are creating your own objects, you can use classes, and then you could define attributes on your own. You can define how it behaves on its own. So instead of like using the addition operator to perform a function to add one number to another number, you could define your own functions to operate on the objects you create. So in this class, I created a class card. I'm not going to explain the syntax too much. I just want you to see that card is the name of the class, which means it's the name of the object. And these are the adjectives or the attributes that go along with that card. So each card has a suit, each card has a value, and then each card is worth a certain number of points in the game. Points in this program, for me, just means the value of a card in the context of the blackjack game. So in blackjack, all the face cards, like Jack, Queen, and King, are worth 10. The number 10 is also worth 10, and then all the numbers are worth what they're worth. And then an ace in blackjack, you can either count as 1 or 11 points. And the idea in blackjack is to get as close to 21 or hitting 21 as possible without going over. If you go over 21, you bust, and you lose the dealer. But if you stay under 21 and you still beat the dealer, then you win. If you were playing for money in a casino, you would win money. But in this game, you would just win points. So I use points. I use score, and I use score in the player class to keep a tally of how many times the person's or a player's beaten the dealer. But I use points in the card class to represent how much the worth of each individual card. So if I created a card object, I could give it a suit, a value, and a number of points for blackjack. So that could be like the ace of hearts, and then it could be worth the value 11 points, because you're allowed to make your aces worth 11 points in blackjack. You could have like 6 of diamonds, and then that would be worth 6 points. And you could have any other card you want. But a deck is 56 cards because there's 13 different cards, and then there's 4 different suits. So that adds up to, sorry, not 56 cards, that adds up to 52 cards. It's 13 times 4. But you have 52 cards in a deck, which I get into in the deck class. But just for the card class, you see that there's attributes that belong to the card, and then these are functions that I define in the card class that can operate on the card. So, for example, I wanted to print a message at certain points in the program that just says like Ace of Hearts or 6 of Diamonds, things like that. And if I ever want to if I ever want to use that function, it would be coming from the card class. So class card, just take away the card as the objects. These values are, or these attributes are the adjectives, and then these functions that go with the class are the verbs. So this is what you can do with the object. This is what helps explain the object, and then the object itself would be the card. So yeah, that's just a basic introduction to object-oriented programming in Python. And again, objects aren't necessarily created by you or classes. They can also be things like integers, strings, anything. Anything that has a value. So if I had x equals 7, that's an object. If I had x equals the word hello, this is a string object, and again, the string is just a message. And yeah, you could create your own objects, or you can use objects throughout your program. So yeah, thanks for watching this video. Check out the rest of our courses at coding-bootcamps.com, and don't forget to take the intro course if you haven't. The link's up here. Thanks. Bye. Hello, welcome to this video by coding-bootcamps.com. In today's video we're going to talk about how to define a class in Python. So the reason you'd want to use a class in Python instead of just creating like list objects or things like that is because it organizes your information a lot more. It lets you write information and manage objects in a lot less code, and everything that's associated with the objects you create all belong to that class, and it just makes it a lot easier to manage your objects. So if you're looking at the course docs, and again, if you haven't taken our Intro to Python course, you want to check out this link. If you copy and paste this link, it'll take you to our Intro to Python course, and then you can get started with the more basic stuff, like what is a list, what is a loop, things like that, because this is a more advanced course. But if you're looking at the course docs, you see this example where we have the names of employees from like the Starship and Star Trek. So you have James Kirk, he's age 34. His title is Captain, and his ID number would be 2265. We have Spock, he's age 35. His position is Science Officer, and his ID number is 2254. And you have McCoy, his name is Leonard McCoy. Oops. He's Chief Medical Officer. Let's just give him an age. Let's say he's 36. And he's got ID number 2266. So I just created 3 lists to define 3 different employees, but this is kind of inefficient because every time I want to create a new employee, I have to create a new list, and the information isn't really that organized because these lists they're not necessarily connected to each other in any way. I just created 3 separate lists. And creating functions could be kind of annoying with these kind of lists too, because those lists wouldn't be related to these.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Those functions wouldn't be related to these lists in any kind of a way. So what I could do instead is I could define an employee class like this. Not define class. Computer's really slow today. So you use the class keyword, you use the name of the class and then colon, and then just like with a function, you don't need parentheses. But just like with a function, everything that's indented below it will belong to that class. So employee is like the name of the object, and then you define variables that go with that object, and you define any functions that can operate on those variables. So if I want to create an employee class, then I need a name, I need an age, I need a position, and I need an ID number. So the way I would do that is I would define an initializer. And we do name, age, position, and ID. So we also need these. We need self.name equals name, self.age equals age, self.position equals position, and we need self.id equals ID. So this is called the constructor of the class, and then every time I want to create a new object of the class, just like if you're creating an integer, you're creating a string or something like that, anything that's passed in to the constructor of the class will automatically get assigned to these variables depending on what the position I put them in. So what I mean by that is I created an employee object in my main program, and I called it employee1, and I use the constructor. So if I do capital employee in parentheses, and then I fill in these four variables in these parentheses, it's going to assign those variables to all four of these within the instance of that class object. So let's say I created an employee and his name's Michael. His age is, let's say, 27. His position is assistant captain. Let's say his ID number is 2200. So I created an employee object here using the class constructor, and I passed it these four variables. So name is the first variable over here, age is the second variable over here, then the third variable is position, the fourth variable is ID number. So I created an employee object, and then I stored it in employee1, just like you would create an integer object and you would store it in X or something like that. And now this would be in the main program, and it kind of used this template or this format to create the object. And now if I wanted to create member functions that can use these member variables and operate on them, I can do it like this. I can define, let's just say, print info, and that's going to print all this information about a specific employee. I could do a print statement. So print name of employee, and we'll do plus ID, self.id, plus name of employee has the name, plus self.name, and the position. So I just made a print function that prints information about the employee, and it refers to all the information that is stored in that employee. So you might be wondering what the self keyword is. What the self keyword is it refers to a specific instance of that class. But the reason you need to put it in the general class like template or the general formatting of the class is because when you're creating functions that use the variables that are defined in the constructor, the self keyword will always refer to one instance of that class. It's not going to refer to the generalized class, if that makes sense. So you need the self keyword because you need to refer to the object, not the class as a whole. So you don't need to put like name, age, position, ID up here because you just have the self keyword and it's going to refer to the instance of the class. And then you'll put like self.id, self.name, and it's going to refer to these variables. So already we're saving time because we're creating a new function and we don't have to redefine what we're passing in as variables because the class is just going to do that for us. So I have an employee class and we defined it up here. We have all these member variables, so these are all variables that go with the class object. And then we have a print statement that's going to print information about the employee. Okay. So I define the employee class up here, and then if I want to create an employee object, I do it in one line like this. It's very short, and I've already got an employee object with 4 attributes. And then if I wanted to use the print function, I could just do employee1.printinfo. And then if I run my code, I had it down here to comment this out. Okay, I run. So the name of employee 2200 has the name Michael and the position assistant captain. And then if I created another employee, let's just give him the name Raphael, the age 34, position, let's just say janitor, and let's just say 2000. Or let's give him a better position. Let's just say he's, I don't know what other positions are. I picked janitor because I don't know what other positions are on the Starship. Just put a comma. And then employee2.printinfo. So you run. And down here you can see employee 2200 has the name Michael and position assistant captain, and the name of employee 2000 has the name Raphael and the position janitor. So it's very, very easy now to create new employee objects and use functions that go with it. So you can create as many member variables and functions as you want. You just keep them all indented under the class, and then they work with that class. So I hope that was a good explanation of how to work with classes. This is a basic introduction. We're going to get into it a lot more about how to use classes efficiently in our next video. And again, if you haven't taken our Intro to Python course, use this link at the top. That'll go over the more basic stuff like loops, like how to use lists, things like that, and how to create them, because this is a more advanced video. So thanks for watching, and see you next time. Bye. Hello, welcome to this video in our Python object-oriented programming course by coding-bootcamps.com. Again, if you haven't taken the Intro to Python course, that's at this link up at the top. You can copy it and put it in your web browser, and it'll bring you to our intro course that goes over things like lists, arrays, just basic data types like integers, floats, things like that, how to write loops. But this is a more advanced course, so you shouldn't be doing this until you take our intro course. But anyway, I just wanted to get into some more things that were in the course docs about classes. So there's this term in programming called mutability, and we say that a class or an object is mutable if you're allowed to make changes to it. So classes by default are mutable because after you create a class object, you can go back and later change that object. So if I wanted to change the name of Michael to George, I could do employee one dot name equals George, and then print employee one again, or print the information of employee one again. So now you can see employee 2200 was Michael, his name was Michael, and now his name is George, but he still has like the same position, and he still has the same ID number. So you can use when I do employee1.name, that's going to go back to the class format, and it's going to say, okay, change the value of the name variable to George from Michael. And you do employee1.name because you're referring to the employees stored in employee1, and then you're referring to the name, which is the attribute of the class. So this shows how classes are mutable because you can go back later and change different attributes of your class objects. It's very easy to do. I also wanted to talk about what happens if you don't give the variables. Well, basically what happens is you get an error if you don't give all the parameters that you need to. So let's say you did you created employee 3, and you did employee, and what's another word? Let's do female, Dana. And her age is 31. And I try to run the code. So I'm going to get an error on line 35, and it's going to show missing 2 required positional arguments, position and ID. So I didn't give all 4 parameters I needed to when I created the employee object, so that's going to throw an error because creating this employee object, just like with a function, it requires me to follow this format. Now you might be saying, why are they saying missing 2 positional arguments instead of 3? Because there's 5 parameters up here and there's only 2 down here. And 5 minus 2 is 3. The reason is the self keyword just refers to the instance of the class. So every time you create a new employee object, the instance of that is already being passed to the self parameter. So self is kind of like, it refers to an instance of the object, but it's kind of like almost not invisible, but it doesn't, you don't need to, as long as you include the self keyword, you don't, when you're creating the class, you don't really need to think about it when you're passing parameters. So when you're passing parameters, you never pass it a self parameter. That happens automatically. And then every time you define new member functions in your class, you would always include the self keyword. So if you created another function, new function, it's all if you use a good interpreter IDE, it's automatically going to put self there because that's all that's required, and then also self is automatically passed to the function. But and then just a couple other things. The pass keyword in the course docs, we talk about the pass keyword just being a way to act as a placeholder for code you don't need, or not code you don't need, a placeholder for a place where you don't want to write code yet, or you don't need to write code. So if you created a function, like, actually I should just bring back that function I had before. So let's just say new function, and I didn't want to write any code for this function, I could just use the pass keyword, and now I'm not going to get an error for having a function with no function definition. So when I run my code, it's just going to pass over this function, see the pass keyword, and then it's not going to give me problems when I run my code down here because it sees the pass keyword. We also talk in the docs about what instantiation means. Instantiation is just a term for creating an object. You hear it a lot with classes when you create class objects, and also assigning initializing variables to it. So when I had employee 1 up here and I gave him the name Michael and the position assistant captain, these other attributes, I'm instantiating an employee object and I'm giving it these attributes.
Thanks for watching. Please like and share this video.
So instantiating really just means creating and assigning initializing variables to it, or initializing parameters to it. So again, this is going to throw an error because there's not enough parameters. So if I want to get rid of the error, give a position, just say, what are the other positions we had? Let's just say medical officer. And then had the ID number 2345. Now if we run, we don't get any errors. I didn't do anything, like I didn't print her information, but now she exists as an object. And then just one other thing to show that two objects are located. I wanted to talk about memory addresses. So when you create new employee objects, if we tested is employee 1 or print employee 1 equals employee 2, whoops, and I run, I'm going to get this word false down here. And what that's saying is that these aren't the same objects because it's checking their memory addresses and it's saying they're at different memory addresses. So it's not saying is Michael and Raphael different people. It's saying are these two employee objects different objects. So anytime you create an object, and that's not just with classes, just any object in Python, that object has to be stored in the computer somewhere at a memory address. So even if you created x equals 3 and you created x equals not x, y equals 7. Well, I don't need to create new variables to show that, but even if you do it with random integers or floats or lists or strings, there's a specific memory address that you're placing objects at when you're creating them. So all the information that's associated with that object, it's stored at that memory address. And that memory address is usually assigned a series of letters and characters that are in hex code. So you might see like a hex number like this, 0. If you looked up the memory address of, this is in the course docs, if you looked at the memory address of a instantiated objects, you would see something like this. This is hex, and what hex is it's instead of like how we use normal numbers, which is 0 through 9 for 10 different numbers, it's 0 through the letter F for 16 characters. So we start using letters because we don't have any other numbers, and there's reasons why we use that, but basically just know that that's the memory address, and if you see it, and that when you create new objects, they have different memory addresses because you're not just creating objects, those objects have to be stored somewhere in the computer, and so they have a memory address associated with it somewhere in the computer memory. So yeah, that's just a few more things about the course docs, and then in the next video I will get a little bit more into methods, and we'll do some review on the topics we've showed so far. Okay, so thanks for watching, and see you in the next video. Bye. Hello, welcome to this video in Coding Bootcamp's Object-Oriented Programming with Python course. If you haven't taken our introductory course, head over to this link because this is a more advanced course, but in this course we're talking about more advanced topics like classes and objects and how to manage them. So today in this video I just wanted to go over a simple example that you can do on your computer, which is create a car with two instance attributes, color and mileage, which have information about the cars, and then I want you to instantiate three car objects, and then I want you to use a loop outside of the class to print the car information, color and mileage. So before I get into it, you might want to pause the video and try it on your own. And I'm going to get into it right now. So to create a car class, I would start like this: class car, colon. You define the initializer, or the constructor. So the self keyword is automatic, and then we need color and we need mileage. And self.color equals color. Self.mileage equals mileage. And then outside of the class, I'm going to instantiate three car objects. So I'll do car1 equals car, just say green 20,000. Do car2 equals car orange 50,000. Car3 equals car purple and has 70,000 miles. Okay. And now I want a print statement that's going to, or a loop that's going to print out all the information about the cars. So I'm going to do for car in car1, car2, car3, print f e car.color. Car has car.mileage, miles. Okay, and I'm going to run. Okay. So this is what I came up with. Yours could look different. As long as it creates three car objects and it prints all the information about them, that's fine. You might have put your print statement within the class, which is okay. But this is what I came up with. So we have the color and the mileage attributes that belong to the car. And again, the self keyword is necessary because that refers to the car, every instance that's created by the car. So every time you're creating a new car object, you have to refer to that instance using the self keyword. I made the print statement outside of the class, so I didn't have a print function. So after I have my car class, I had three car objects. I have a green car, an orange car, and a purple car, and they all have these different mileages: 20,000, 50,000, 70,000. And then I made a loop that loops through all three cars and uses this format to print the information. So if you use curly braces like this, and then you pass it the attribute, which is the color attribute of the car, using car.color, this is just going to fill into the string the car color and the car mileage as it loops through all these three values. And then that's how we get the print statement at the bottom, which or the three print statements, which is the green car is 20,000 miles, the orange car is 50,000 miles, and the purple car is 70,000 miles. So the F string here, this F, that's part of the string which allows us to insert attributes into a string. But yeah, this is what I came up with. If you want to modify a little bit of this, you can add extra functions. You can add functions that work with the member variables. So if I came up with one, maybe just some more print statements, or a function that can convert mileage to kilometers, things like that, you can add to your class and you can practice it. As long as you just remember when you're creating new functions. So let's just say convert miles to km. Again, you don't need to, if I was going to convert miles to, or let's say mileage. So if I wanted the mileage in kilometers, then I could put the math down here. So I think miles in a kilometer. Yeah, so 1 kilometer is, or let's do kilometers in a mile. Okay, so there's 1.6 kilometers in 1 mile. So if I wanted to create a convert to kilometer function, I would say print self.mileage times 1.6. And then I could do I'll do this car has driven, I'll do string miles and then close. Then I'll do car1 dot convert mileage to km. Car object, car object has no attribute, convert mileage to km. Must have misspelled it. I'll just put everything lowercase. Yeah, I misspelled it. Okay, run. Yeah. So I converted the mileage. It's not a, it's a rough estimate of how many kilometers it is, but it converted the 20,000 into, oh, and shouldn't have put miles, I should have put kilometers. Yep. So the green car has 20,000 miles on it, and then I did car1.convert mileage to kilometers, so it printed the statement this car has driven 32,000 kilometers. So you can modify this function to you can do car or the self.color so that'll give the color of the car. I need my addition strings. I run. So now it prints the green car has driven 32,000 kilometers. So yeah, you can just add more functions if you want to this class. Just remember the formatting, and you can improve the class and just mess around with things just to make sure you have class concepts down. So yeah, thanks for watching this video. In the next video, we'll get into more new topics, and we'll do more projects coming up pretty soon. Thanks for watching, and bye. Hello and welcome to this video by coding-bootcamps.com. Today I'm going to talk about inheritance in Python and how you can use it to further develop the way you define your objects in your programs. So we already went over creating classes in Python and how they're a way for you to define your own objects and have variables or attributes and methods that are associated with them, and it organizes everything in a nice clean way, and it works a lot better with programming than trying to use the base objects of Python. So today when I talk about inheritance, I'm going to get into how you can develop more specialized classes and how those can use a base class or an abstract class to save you space in coding, and also have more organized programming and make your objects work better together. So to begin, I'm going to talk about I'm going to come up with an example. It's called it's in the course docs, but you can see in section 4 there's the dog
Thanks for watching. Feel free to add your questions as comments down below.
class. It looks like this. You have class dog, species, genus, human, initializer or constructor, name and age, and we have a string function that we created. Turn up. And we have a speak function. Okay. Okay, so we have a dog class. We define a variable called species, which is always general to what a dog is. We have two variables, name and age, and then we also have two functions. One that prints out a string, how old the dog is, and we have another thing, another function that gets a dog to speak a sound. So you can have dog objects, but dogs can also be. There are lots of different types of dogs that can all belong to the same species of dog. So, for example, you could in the docs, like you could have a bulldog, you'd have a Dachshund, you'd have a Jack Russell Terrier, you could have a Labrador. There's all different types of dogs, but they all belong to the same species. So the reason inheritance comes into play into this example is because there's certain methods and variables or attributes that we could define in the dog class that we could use in a more specialized class that is a type of dog. And then each of those specialized types of dogs could have their own unique functions that we would only want those types of dogs to have, but they could also, the specialized classes can use the base classes functions and attributes. So just to show a little bit more what that means, we could create 3 more classes. Use the one in the doc. Use the ones in the docs. So Jack Russell Terrier. Okay. And for now, I'm just going to put pass. Remember, pass just means that there's no code there, but it won't throw an error because we have the pass keyword there. Okay, so I'm creating 3 more classes, and they're a more specialized type of dog. So Jack Russell Terrier, Dachshund, and Bulldog are all types of dogs, but we want them to all be able to use the attributes and the methods in the dog class. So what I did was I put in parentheses dog for all 3 of them. And what that means is it's going to inherit all of these attributes and these methods from the dog class. And then we're also going to be able to add on to that code within each specialized class for more specialized functions and attributes. But the nice thing about this is we don't have to rewrite all this code for each of these specialized classes. We just have to inherit the class, and it already gets to use all of these. So for example, if I created a, comment this out, last video. So let's say we created 4 dogs, and we gave them names. Again, this is in the docs. Okay, so we just created 4 new dogs, and they all have their own names. 2 of them are the Bulldog type. One is the Dachshund type, and then one is the Jack Russell Terrier type. But the thing is, all 3 of these types of dogs inherited the dog class, so if we wanted to, we could use a dog function with these variables which hold a more specialized object. So what that means is we can get the name of the Jack Russell Terrier by doing miles.name. Okay, so I just printed the name Miles, and name isn't defined anywhere in Jack Russell Terrier. It's only defined in dog. But we created a Jack Russell Terrier object and stored it in Miles. So what that means is we're accessing an attribute of the dog class through Jack Russell Terrier, because Jack Russell Terrier inherits dog. So an inherited class, basically a child is inheriting from the parent, just like genetically, like we explained in the docs, just as an example. The parent has a bunch of base functions, and then the child class has more specialized functions, but the child class can use the parent class's functions and also attributes. So if we also wanted another one of these dogs to use the speak function, which is also defined in dog, we could do this. We could do speak and say woof. Click in the docs, and then if we run, okay, so we printed out Miles says woof by passing it the string woof and using the speak function. So yeah, so we were able to create a Bulldog object, but Bulldog inherits dog, so it inherits all of the methods from dog. So we were able to use this function even though you don't see the code in the Bulldog class. And that's because Bulldog and all 3 of these specialized classes inherit the parent class. So yeah, just to take away from this video, parent classes can give methods and attributes to child classes, and using a parent-child relationship, which is also inheritance, you can relate classes to each other in a way that organizes your programming a lot more and makes objects a lot more understandable and how they're related to each other. So yeah, if you like this video, next time we're going to be getting a little bit more in depth on the functionality of parent classes and child classes. And yeah, if you haven't taken the Intro to Python course yet, the link's up here at the top. It has all of the introductory Python syntax and like grammar and things like that. Just goes over basic concepts like loops, arrays, if statements, things like that, in case you feel you weren't ready for what we went over today. So yeah, thanks for watching, and check out our next video. Thanks, bye. Hello, welcome to the next video in our Python object-oriented programming course. Again, if you haven't taken the Intro to Python course, the link's at the top up here. In this, we go over more basic things like loops, arrays, lists, if statement, and just like basic syntax in Python to get you started. This is a more advanced course that goes over higher level concepts, so you shouldn't be taking this until you've at least taken our intro course. So today I wanted to get into how to extend the functionality of a parent class, just like in the docs. And we're going to use the dog example again. So there's something in inheritance called overriding a function in a child class. It's kind of like when you it has a lot to do with scope. It's kind of like when you have a variable in a main program and then you define a function and you use the same variable, but it's only local to that function. It's the same thing with classes where you can redefine a function that's in a parent class specifically for a more specialized child class. And then you can change how it works a little bit without changing the base method of the parent class. So what I mean by that is, let's say we wanted Jack Russell Terriers to have a little bit of a different speak function, but we didn't want to change the speak function in dog because we wanted to use that in the other two dog classes. Well, then we'd have to redefine speak in Jack Russell Terrier because we want it to only be a little bit different for Jack Russell Terrier. So let's say we put some code in. We defined a speak function. And we wanted to give Jack Russell Terriers the default sound, which is arf. And we set it up like this. Have self.name says sound. Okay, and sound doesn't need self because sound is being passed in only for the function, not as one of the attributes of the class. So notice how we didn't define sound in the constructor. It's only a parameter for the speak function. That's why we don't use self for sound. It's only relative to the function, not the entire class or the object. So yeah, so we redefined the speak function for Jack Russell Terrier, but we made the default sound arf. So even if we don't pass in an argument for sound, the Jack Russell Terrier is going to say arf. So if we did print speak woof for Miles again, and then let's just say we print it again. And then we run. So it says, Miles says arf. So if we pass an argument, it would use the argument, because this is called a default argument, where we put in an argument in the parameter definition, so that when we don't use a parameter when calling the or using the function, it'll automatically use arf instead of just doing nothing or throwing an error. So so if we pass the speak function to our Jack Russell Terrier Miles, he'll say woof. But if we don't pass a parameter, he'll use the default, which is arf. But we have a little bit of a problem, which is we kind of had to redefine the function, and we might not want to change certain things about the parent function. So if you look at the course docs, we wanted to change the dog function a little bit and change the formatting, so we did.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Change says to barks. And let's start dashing, buddy. So put it a little bit above. Okay. So we changed the parent function, speak. So we changed says to barks, and we put a colon in. And then we use the speak function with buddy, who is a dachshund, and we use the speak function with, down here we used speak with buddy, who's a dachshund, and then we use speak with Miles, who is a Jack Russell Terrier. But as you can see, Buddy has the same formatting of the parent class, but Miles doesn't. So how do we redefine the function in Jack Russell Terrier to have this default argument for the parameter without changing the formatting or completely redefining the function or just copy and pasting this code over here? Basically what I'm trying to say is, how do we get to say Miles barks woof and Miles barks arf without completely rewriting this line of code? Well, that's where we would use the super function. So instead of rewriting this as barks, which is the same thing we wrote here, you could do this. Return super dot speak sound. Now if we run, you see Miles barks woof and Miles barks arf. So what we did was we redefined the speak function in Jack Russell Terrier, but it's going to reuse this function and then just with a default parameter this time. And we use the super function to do it. So what the super function does is it goes back to the parent class, it gets the speak function from the parent class, and then we reuse it down here. And then we pass it sound as an argument. So this sound is like this sound. But super means use the parent class's code or use the parent class's function definition. And then all we did was we passed it a default parameter. So now we're using the speak function in Jack Russell Terrier, but it's a little bit more specialized, which means Jack Russell Terrier now has arf as a default parameter for sound. So if we did, again, when we did Miles.speak, we kept the formatting from the parent class up here without having to rewrite the code, and we have a default parameter now for Miles, who's a not for Miles, for Jack Russell Terriers that other types of dogs don't have. So if I did print buddy.speak and I didn't pass it an argument, I would get an error. See, it says we're missing a sound argument. So I'll just move this a little bit so it's more organized. So I got an error on line 53 here when I tried to use buddy.speak, and I didn't pass an argument. So the reason for that is because we defined a default argument in Jack Russell Terrier speak, but Bulldog, when he uses speak, he goes back up to the parent class, but there's no default parameter for this. So we're getting an error because we're not giving a parameter to the speak function for Buddy, who is a dachshund. And dachshund requires a parameter to be passed into the speak function because it's using this speak function. So yeah, if we wanted to make it so Buddy could speak without passing a parameter, we'd have to copy this down here. And let's say we wanted to change it a little bit different. So his default sound is roof. And now if we run the code, you'll see Buddy says roof and Miles says arf, and it doesn't pass an error anymore. Because now dash-ins also have a default parameter for sound. Yeah, so that's just a little bit of an explanation on how you can extend the functionality of parent classes. You can use the super function to refer to the parent class's version of a function, and then you can add on to function definitions. Just remember that when you do this, there's a term called overriding the parent function, which means anytime you use a dash-in, it's automatically going to use the newly defined speak function instead of the parent class's speak function. The only time it's going to use the parent class's speak function is if there's no function definition for it in the child class, in the more specialized class. So yeah, that's how overriding works. And overriding will always choose the most specialized, or the furthest down in terms of children, as long as the function is defined in that class. So yeah, I hope this helped explain how inheritance works a little bit more, and how you can change functions within child classes. And next time we're going to be going over an example just to reinforce how to use super and how to extend the functionality of parent classes. Thanks, and see you next time. Hello, and thank you for taking our object-oriented programming course in Python. I'm just going to go over some of the things we learned, just to review what you actually gained from this course. So we went over what object-oriented programming is. So that would be the relationships between our classes, our class objects, and their variables, or their attributes, and their methods, and how they interact with each other. We learned how to define a class. So like in our blackjack game, we created a player class to represent the players, their scores, their names, and also the player hands. We learned how to instantiate an object in Python and what an instance is. So an instance would be like creating the physical players in the main program, and then instantiating them by asking for their names, the players for their names, and then also initializing their points and their score to 0. We learned about class and instance attributes and instance methods. So we learned how to initialize class attributes in the constructor. So the very first function of a class, like if you have the class player, is you have define underscore underscore init underscore underscore, and then we had the parentheses self, and then we'd list all of the variables after that, and then we'd initialize the variables beneath the initialize function or the constructor. We also learned about inheritance. So that was mainly the car program, where we had like the sedan class, and we had the convertible class, and those were based on a parent class which was called car. They were able to inherit attributes and methods from that class, and then also extending the functionality of a parent class, which is basically the same thing as inheritance, where you have a parent-child relationship between a class and all the classes that inherit that class. And then just to go over the 3 projects we covered, we had the car class with 3 subclasses, which was the project that covered inheritance. We had the guess the rolling dice program, where we had players pick a number from 1 to 6, and then if it matched the number that the program picks, then they get a point, and then the winner at the end of the program was the one that the player that had the most points. And then we had our blackjack game, which was the biggest program, where we created a deck of cards using classes to represent the cards, and then we had the program deal cards to every player, including the dealer, and then players could hit until they tried to get as close to 21 points as they could without going over, and they would play against the dealer. And then if the dealer busted, or if the player had more points than the dealer, then they would be awarded a score. and then at the end of whatever number of rounds they played, the player with the highest score was the one that won blackjack. So I hope you learned a lot about object-oriented programming. If you want to check out our other courses, we have Intro to Machine Learning with Python and Intro to Data Science, Data Analytics, and Data Visualizations with Python. So you can check out those on codingbootcamps.com, and be sure to follow us on Facebook and other social media if you want to keep up with updates and other courses that we'll be offering. So thank you for taking our course, and have a nice day. Bye.